Welcome. So this question says, consider a parallel plate capacitor that is used to create a uniform electric field of 6 newtons per coulomb. What is the potential difference between 2 points A and B? A capacitor is a component on which we can place charge. So we have a positive plate for a capacitor and a negative plate for the capacitor. The positive plate would be connected to the positive terminal of a battery, and the negative plate will be connected to the negative terminal of a battery, for example. It creates a nice uniform electric field. And so here we have a visualization of it. The gap between the two metal plates is 8 meters, and I have one point of interest which is at 2 meters from the positive, and another point of interest which is at 5 meters from the positive. And I'd like to know the potential difference. It's my, if you like, it's my delta V. Now, I've not said if I'm going from positive to negative or negative to positive, and we'll talk about that in a minute because it does make a difference. But for the moment, I'm envisaging going from A to B. So there's nothing moving, there's not a charge moving, it's just my interest is moving. It's a bit like looking at a map and saying what's the difference in height between this point on the map and that point in the map. I'm saying what's the difference in potential between that point on the diagram and that point on the diagram. So what I learn is that my change in potential, my potential difference, is equal to minus E times D. E is the electric field and D is the displacement from A to B or B to A, depending on which direction I go in. So in this case, I'd say, well, my delta V is equal to minus and E and D. Well, E is 6 newtons per coulomb and it's uniform, so it doesn't matter whether I'm near one plate or near another plate or near one edge or near another edge. For a uniform electric field, it's nice and uniform. So E is the same all over the inside of these two plates, and so E will be 6. And then D, well, I look at my points of interest and I know I'm going between a position that's 2 meters from the top plate and 5 meters, and so my delta X, if you like, is going to be 5 minus 2. So this will be minus 6 times 3. So delta V is equal to minus 18 volts. The unit for voltage. The unit for potential difference is the voltage. Now, what's this minus sign telling me? What the minus sign is telling me is that my displacement, as I'm envisaging it, is the same direction as my electric field. So going from A to B, the change in potential is 18 volts negative. And if I went from B to A, the potential difference will be 18 volts positive. And I can show you that really with an analogy and say, here's my two plates. I'm drawing a kind of three-dimensional diagram. So here's my positive plate and here's my negative plate. And the uniform electric field can be represented as a nice embankment. And so I have my point of interest A and my point of interest B. And we see we're going from if we go from A to B, we're going from a high position to a low position in terms of a kind of gravitational or a height analogy. And in going from A, which is near the positive plate, to going to B, which is near the negative plate, I'm going in line with the electric field. I'm going to lower potentials. So I could say this is high potential and this is low potential. So this negative sign is a way of keeping track of that. Are you effectively going downhill, in which case your sign would be negative, or are you going uphill? So to make this a bit clearer, why do we put down V? Well, I need to do two things. One is uniform, because it's not always going to be this equation. So let's just make sure we remind ourselves of that. For a uniform field, this equation holds. And then let's say it's from, how shall I write it? From A to B. I'm making up this nomenclature to try and explain things. So when I go from A to B, my potential difference is minus 18 volts. When I go from B to A, my potential difference will be plus 18 volts. If I wanted the magnitude of the potential difference, I would say it's just 18 volts. I could ask you which is the higher potential and which is the lower potential. And you'd say A is a higher potential, and you'd say B is the lower potential. The electric field points from high potential to low potential. So there we have it.